So, hey, it's Rodney Utt, your CT111 instructor for your lab component of the class. I'm here in David James's office, a company that he's the founder and CEO of. Is that correct, Dave?
That is correct.
Insulate Santa Barbara. And we're going to be talking to Dave for a bit. We're going to tour his facilities and talk about insulation and thermal protection. I guess that's it, right? That's the name of the game. So, Dave, could you please introduce yourself and just tell us a little bit about yourself and how you got into this business and what you do.
Okay. So I got in the business through my father, Ken James, who was a drywall, lathing, plastering contractor in the 1960s here in Goleta. And towards the end of the 60s, when insulation started becoming a requirement on some projects here in Santa Barbara, my father found himself in a position where the insulation contractors were holding up his projects. So he became an insulation contractor. In about 1968, that was kind of my first experience with fiberglass and unloading truckloads and things like that. Fast forward to about 1974, that's when my father became an insulation contractor 100%. And I started with him doing some small projects. I remember the first time that I got involved with doing a blown insulation project. I was feeding the hopper, and the guy that was working in the attic, he decides that it's my first day to learn how to do blown insulation, crawling up into an attic. So he hands me the hose and he says, just go for it. You know, it's just like watering the lawn. And so I get up there, and I'm trying to put in 2 inches of insulation in the attic. That's the requirement back then, which was hardly anything. So I'm basically running through the attic, and I end up stepping through the ceiling. First house, you know. And it happened to be one of those, 1x1 panelized sound ceilings that are expensive to patch. Well, I heard a little bit of that from my father at the end of the day. So I kept working with my father, learning the trade, and in about 1978, we started another company called Santa Barbara Insulation with me, my father, and 2 other partners.
Were you still doing hung ceilings? Was Kenny? Did you ever do hung ceilings?
No drop ceilings.
You pretty much just got into it doing the insulation?
Insulation. Well, it was in 1976 that insulation started becoming a code requirement for residential. And so in 1977, 78, they had an amazing shortage of insulation.
And tell us about that, but before I'm going to interrupt you, so I want you to finish your bio, get us up to date, and then if you wouldn't mind, help me remember, go back and tell us the principles of what you do too, like why we're doing it. But before that, let's finish your bio.
A little bit more about me. So 78, we started that company. Fast forward to 1985, I purchased the business from my father and groveled through the 1980s, barely making it, pretty much not making it. Coming to the 90s, pulled it together and did pretty well. Ended up selling the company in the year 2001 to a major corporation. National, yeah, Masco Corporation. Yeah. And stayed on with them for about 10 years, and then started this company, Insulate SB, in 2011, and built it up to where we are today. And we specialize in custom homes. Spray foam technology is our real winner. We've kind of promoted that product throughout Southern California, and we cover areas from San Simeon down to Laguna Beach. Reasons we want to insulate. We basically are looking at a home a building that's trying to equalize the temperature and the air pressure between the inside and the outside consistently. So whatever the temperature variance is outside, it's trying to equalize that into the inside of the building. And if it's windy outside, that wind's trying to get inside. If it's humid outside, it's trying to get inside. If it's dry outside, it's trying to get inside. And we're trying to create an environment that's comfortable for people to live year-round, So I don't really have to think about turning the heater on or the AC on or being uncomfortable in general. Codes have followed the requirements of controlling certain temperatures based on the energy consumption and energy costs. So when we first started out, it was R11 in the walls and R19 in the ceilings. And today we're seeing projects with R60 in the ceilings and R50 in the walls.
Holy crow, stop for just a second there. So, and that's on purpose.
Well, there's reasons behind that. Specifically windows. Windows there's a mathematical formula that allows a person to put in more glazing if they have more insulation. Now, the numbers work on math, but in actual field conditions, it doesn't really work. I mean, glass is glass. The best glass in the world really is an R8 value.
Yeah.
And that's triple pane.
Okay, wait a second. Now, even triple pane only gets you R8?
About R8.
Surely you could get bigger than R8, right?
Maybe with some argon gas. I mean, I don't think
So
I've seen
right
but
now-
one project with triple pane glass.
But so right now, the max double pane, say quarter,
Mhm.
3/4 spacer would give you R8. That would max out at R8.
I don't think it's that high.
Wow.
Yeah.
And then what you've got is you've got a coefficient for the fenestration of the house.
Mhm.
So you can have so much square footage of the house, percentage of the house
Mhm.
in glass, and if you go over that, then you have to increase the insulation. And the walls that don't have.
Well, there's
Obviously
some
don't have glass.
variables with that. I mean, if you add in solar, you get some advantage points for solar. If you have a tankless water system, you can get some benefit from that. If you have a high efficiency furnace, you get
So
benefits from that.
All these things would contribute to you being able to have more glass than the
Mhm.
code allows based on square footage of the project.
Mhm.
Yeah, you get a little bit more glass area for a on-demand water heater, a little bit for Icynene foam, right? For close-cell foam.
Well, not so much.
Open cell.
Not so much for the foam. I mean, there's some advantages to a conditioned attic where you're conditioning the roof assembly instead of the floor assembly of the attic. And if your duct system happens to be inside the attic, now we're keeping the ducts in a conditioned space, which gives you an added advantage. Mhm.
So, tell us about conditioned versus
Mhm.
unconditioned spaces, because that's like key
Mhm.
in your job, right?
Well, we look at a house typically has an attached garage. The garage typically is unconditioned. That doesn't mean we wouldn't want to insulate the roof assembly of the garage, but the unconditioned space means that we're not providing any heat or cooling to condition that particular space. Whereas the house, we're trying to keep it at a specific temperature through the introduction of heat or cooling. And that pulls in the code requirements for us to have to insulate. Mhm.
And so where has insulation gone from R13? Is it still R13 on the 3.5-inch wall?
For existing structures, R13 is still applicable for existing structures. We have a 2x4 stud.
And is that the max you can get on a 2x4 stud is R13?
No, with bad insulation we get an R15 with fiberglass material or rock wool material. We get an R15 and a 2x4 stud, but the cost of that material is the same as R30. So you don't want to go there if you can work around it.
Wow. So an R15 is the same cost as an R30 just because it's designed to fit in a 3.5-inch wall, I guess.
Well, it's basically a very thick material compressed down to 3.5-inch
Okay.
material. Hence, the weight of the material is similar to an R30. So they basically look at the poundage of the material and base that on the cost.
How has your job changed from when you started doing it in '68, unloading trucks and your dad's, and you started putting bats in walls and stapling? They're all paper-backed, right? And you had flange that you stapled
Mhm.
inside a stud bay.
Yeah, that was pretty typical to see a vapor barrier on the insulation itself. And some of our contractors, they loved foil face material because it looked pretty, made them look good. The owners loved it. But we fast forward to portable phones, cell phones or home phones. They found that the foil facing on the insulation caused interference with the portable phones. So we pretty much stopped using that basically in the kind of mid-90s. That kind of went away. Vapor barriers are really not a true vapor barrier because it's not sealed. It's a misnomer, I think. I think the only way you can get a true vapor barrier is a monolithic covering that's overlapped and taped. Plastic, for example. But different environments, different locations around the country require a vapor barrier or not a vapor barrier, and it could be on the outside of the building or the inside of the building, depending on the amount of humidity in the air or lack of humidity. So we typically use unfaced material, and part of that goes back to code officials in their striving to do the best that they can. Went to the online videos that were available to them through the California websites, and they showed where vapor barriers were installed that they had to face staple the flanges onto the face of the studs. Now, this application caused total havoc for the drywallers. When we first started doing this, drywallers were putting a hit out on my life. Seriously, they were very, very upset. And building officials were having a difficult time with looking at projects that had, let's say, less than 16-inch on center framing. We couldn't face staple both sides because it was cut to, say, 11 inches, and you had to cut it down. So it went away pretty quickly using the face material.
So when you say face staple, I want to make sure, and I'll probably explain this to them when I show this video. But so that at the end of the bat, which has got paper across one face,
sides of the bat,
it's a little tab on either side that would go over the face of the stud, and it's perfect at 14.5-inch stud bays that would lay over and staple, right?
Yes.
And from both sides. But yeah, anything less, you're only going to get one. They didn't require you to tape it or anything like that?
Yeah, they didn't show any requirements for taping, but
so how, that's one way I know it's changed. But what about pricing? Because we've seen everything go up in price, but just thinking about what insulation costs, like you know of back in the 70s, what bad insulation costs versus today, how does it compare?
You know, as far as the cost of other items, it hasn't followed the same suit. And part of that is
other building materials.
Well,
concrete.
Maybe not building materials, but maybe like food products or clothing products. Other products that I'm aware of, it hasn't gone up that much. But what has really changed is the application of how they're packaging the material. In the 70s, everything was paper-faced. The wrapping of the bag was paper-faced. There were individual bags. And fiberglass can compress down to a very small amount of space, considering how much comes out of a bag. A typical bag is, 100 square feet, and it's 1.5 by 1.5 by 4 foot long, and 100 square feet of 6-inch material.
That's 10 cubic feet.
Yeah.
Becomes 100 square feet.
Absolutely. So what they started doing was they changed from paper-faced to plastic. And when they first started doing that made a huge difference. And then they started shrink wrapping straps around the bags themselves. So we went from individual bags to a 4-pack. And then they went to a 5-pack, which was the same space as the 4 bags that was compressed.
Is this Johns Manville? Is that pretty much?
All manufacturers, yeah, all manufacturers. The first insulation plant that I went to was in 1978, and it was in Chowchilla. It was a Certainty plant, brand new. They had, at that time, I think, 58 employees. I went back in, I think it was 1986, and they had, I think, 12 employees.
Huh.
Everything was automated.
Oh, yeah.
Unbelievable. Yeah. And the same happened on another plant that I went to up in Willows for Johns Manville. It was just amazing how much technology had changed in their ability to package everything using mechanical equipment versus labor or handheld labor.
Yeah, and they're making the same thing and lots and lots of it. Perfect candidate for robotics and CNC controlled.
But, well, one of the things that did change a lot during that time period is going from the use of sand to recycled bottles.
This is to make the glass?
To make the fiberglass, yeah. The percentage is roughly around 40% of the fiberglass material is all recycled glass.
Okay, so
billions of pounds.
tell us about that, because I'll bet nobody even knows how do you get the material that you're calling fiberglass, and then after you tell us about that, I want to remind you to talk about rock wool and stuff like that. But fiberglass, that's the most used material, most common material for insulation, craft backed or not, or unfaced. And what is it? What is it? Where does it come from?
Well, silica sand is the main component in the product.
Just like glass.
Yes, just like glass. And they put in a couple other little special things. They don't really tell us exactly what it is. But the two plants that I've gone to, the line is about 300 yards long. Yeah, it's an amazing process where they start in a large box, basically with a spinner that looks like a colander, and they pour molten glass, which is, I mean, you can barely look